When we multiply by 100, we move 2 place values to the left. So with 9 times 100, we move the 9 2 places to the left, so it's moved from the units to the hundreds column. And then, if we have empty place values before the decimal point, we write in zeros. So 9 times 100 is 900. And it's important to recognise what we're doing here. We're moving digits 2 place values to the left. We're not just writing 2 zeros at the end of the number. This is important because writing zeros at the end of a decimal number doesn't change the number. So if we have 0.6 times 100, we can't write 0.600 because that's the same number. Instead, we move 2 place values to the left. We need to write a 0 in our empty units column to show that we now have 6 tens rather than 6 units. But we can ignore the 0 in the hundreds column. So 0.6 times 100 is 60. What is 0.7 times 100? $70. What is 4.5 times 100? $450. Notice that 4.5 is the number halfway between 4 and 5. Now if you know that 4 times 100 is 400, and 5 times 100 is 500, you know that 4.5 times 100 will be 450, halfway between 400 and 500, because 4.5 is halfway between 4 and 5. What is 8.9 times 100? 890. Now if you know that 8.9 is close to 9 and 9 times 100 is 900, you know that 8.9 times 100 will be just under 900. This is a useful way to check your answers. Round decimals to the nearest whole number and check that the answer you get is close to what you've written. Now we have 0.04 times 100. So moving 2 place values to the left, we have 4 units, and we can ignore our 0 hundreds and 0 tens. So 0.04 times 100 is 4. Now here we have 4 hundredths of one of our large rectangles shaded. If we coloured in 4 squares 100 times, we would have all 4 of our rectangles completely shaded. But here's another way to think about 0.04 times 100. Let's split up these 4 hundredths, 1 hundredth in each rectangle, and now it's easy to see that if we colour 100 times as much, we've coloured 4 full rectangles. So 0.04 times 100 is 4. So what is 0.02 times 100? .02 times 100 is 2. 0.81 times 100 is 81.